Hey folks, welcome in. I'm going to give everybody about 60 more seconds to join in before we get started. All right, I think we're about a minute past the hour here, so I'm going to get us going. Welcome everybody to Integral Consulting's engineering practice webinar series. This is the first of 4 webinars that we'll be putting on over the next few months that use some case studies from our projects to highlight some of the unique challenges that we've dealt with and some of the out-of-the-box solutions that we've employed to solve the problems and issues. Keep an eye out for invitations for future webinars that will be picking back up after the holidays in January. My name is James Lesperance. I'm an engineer at Integral, and I'll be moderating today's discussion. Couple housekeeping items before we get started. All attendees have been muted. If you have questions during the talk, please ask them. We're hoping for a good discussion at the end of the talk. We'll answer as many questions as we can. To ask a question, use the Q&A button at the bottom of the Zoom screen, and you can type a question in right there. This webinar is being recorded, and all attendees will receive a link later today or tomorrow with the recording of this discussion, as well as a link to the slides that are presented today. Contact information for the speakers will also be provided at the end of the presentation. So please reach out if you have any follow-up questions. With that, I will be handing this over to Susan Welt to begin the talk.
Thank you, James, for the introduction. Today, we're going to speak about the vapor intrusion pathway, the first in this series because it's the start of the colder months and typical sampling season to assess this pathway. However, by the end of this webinar, we hope you will understand that the process of evaluating and addressing the potential for vapor intrusion to impact a building is not based on the season. Rather, to create a healthy building and community effectively and efficiently is a continuous strategic risk management process based on stakeholder goals. As we know, the vapor intrusion pathway occurs when vapor-forming compounds in the subsurface migrate through preferential pathways into overlying buildings. These compounds can be naturally occurring or from manufacturing operations and include semi-volatile organic compounds, volatile organic compounds, mercury, methane, radon, and some PFAS, pesticides, and PCBs. And very low concentrations in the subsurface, even below drinking water standards in groundwater, may pose an inhalation risk to building occupants. As a review, vapor intrusion pathway consists of 5 elements. We need a subsurface source of vapor-forming compounds or chemicals in the subsurface, so in the soil or groundwater, underneath or near buildings. Vapors can form from this subsurface source and have a route along which to migrate or be transported toward the building or buildings. The buildings are susceptible to soil gas entry. So this means there's preferential pathways, maybe cracks in the subslab or the slab, sewers, there's a block foundation, whatever it may be. And there's driving forces to actually have the vapors be able to migrate into the building through these pathways. One or more of these vapor-forming chemicals that are in the subsurface are or is present in the indoor air. And the most important one I would like to focus on is that the building is occupied, or if there's more than one building, the buildings are occupied. If one or more of these conditions is currently absent and is reasonably expected to be absent in the future, vapor migration is significantly and persistently impeded by natural geologic, hydrologic, or biochemical processes and conditions, for example, then the vapor intrusion pathway is referred to as incomplete. Although it may be currently incomplete, the pathway may exist and therefore it may also be considered a potential pathway to be addressed in the future when conditions change. We all know that environmental conditions change, and so therefore we have to think about whether or not that potential pathway will remain incomplete. Guidance documents indicate that groundwater, soil vapor, subslab, indoor air, outdoor air data, as well as the knowledge of building conditions and internal sources can be used to evaluate the potential for vapor intrusion to impact the indoor air of a building. These data serve as useful tools and lines of evidence and can indicate whether there's a potential or current complete exposure pathway. However, as Keith will discuss in detail in a few minutes, to develop a risk management approach to be protective of the vapor intrusion pathway now and in the future, one also needs to understand the current and future use of the building, property, and surrounding area, site geology and history, the property owner and building occupants' tolerance for potential long-term operation maintenance and monitoring or additional sampling, potential for changing subsurface conditions, the regulatory, political, and community concerns, and the implications of these decisions. So it's not just really the data that we're talking about. It's about what are we going to do with all this information? Dose response exposure assessments demonstrate that inhalation of these compounds, which may be present at low concentrations, can pose an acute or chronic health risk, or even a near-term safety health hazard to building occupants, as shown here. These results can result in concern and fear in the building occupants, perceived reduction in property value, resentment of potentially responsible parties, and unrest in the community. And to collect the data means going to someone's home or building and really looking around, opening closets and cabinets, taking pictures, documenting building conditions, and making recommendations to remove chemicals. I don't know about you, but sometimes it's really a concern when someone comes to my house and it looks a little messy and we want to clean it up, but sometimes we don't have that option. Therefore, knowing when to collect the data, what to do with the data, and how to interpret and communicate the collected data is a strategic risk management decision and is based on an understanding of the stakeholders' intent and goals with consideration of their interest in managing liabilities, continued involvement with the property, and property use. By working with the community and its stakeholders, we strive to understand the current and future use of a building and develop an approach to address the vapor intrusion pathway that supports healthy buildings and healthy communities. This risk management approach includes understanding the potential risks, sources, proposed remedial efforts, data over time, and stakeholder efforts, interests with the intent to build trust and effective communication. And as shown in the picture on the right, it's a continuous feedback loop as more information is obtained, regulations, risk tolerance, and stakeholder needs evolve, and site and building conditions change. So we really have to think about what's going on, as Keith is going to discuss in the next few slides of how these elements are implemented.
Thanks, Susan. And so, as you discussed over the last couple of minutes, the real value in using the strategic risk management approach is to collect the correct data to evaluate and control risk under current and future exposure scenarios. And one of the greatest benefits is the ability to communicate with the stakeholders. And there are many stakeholders, I have to say. We'll talk about some of the case studies we've had where we've had even elected officials get involved as stakeholders. And Jess, if you can give me control of the presentation, that'd be awesome. Thank you. And we're using this strategic approach to talk with our stakeholders about the why. Why do we need to get access? Why do we need to go into their personal space, collect these samples, which, as we're collecting air samples, we're detecting what people are using, what they're doing in their space. We see their personal lives. As Susan said, we're opening closets. It's uncomfortable at times. And we want to talk to the stakeholders about it. And we want to discuss with them why we collect that, but also why do we need to share that information with others. And so using this approach, it helps us to discuss the what ifs with those stakeholders as well. What if we can't obtain access? What if we find something? What did the data show? We want to develop those relationships so that we can have those deep conversations. And this allows us to communicate effectively in a consistent and clear manner that promotes trust and enables implementing a more cost-effective and timely vapor intrusion evaluation, and ultimately a remedy, which is how we're reducing risk overall. And so risk management, let's talk about that. And here, with our risk management approach, with our risk management approach, we want to understand the purpose for an evaluation or a control measure. And that really allows us and our stakeholders to collaboratively develop strategies that really promote that long-term health of the building and health of the community. We want to make sure we're only collecting the data that's necessary to make a decision, right? There's no reason to collect extra data or too little data. We want to make sure that we're focused. So as we're speaking with our stakeholders and we're developing this approach and designing a sampling plan, we want to make sure that we're going out as little as we need to, but doing as robust of an investigation as we can to answer the questions and to make the decisions that are necessary here. And this goes back to the CSM, the conceptual site model that Susan discussed earlier when talking about the vapor intrusion pathway. We want to make sure as part of that CSM evaluation that we know what the building is currently used for, or as you see in the slide here, what the building might be used for after construction, because that's really going to change how we are evaluating the building, how we're designing this investigation. And if it's necessary, it goes to how we're designing that control measure. We may adjust our investigation or our mitigation approaches depending on whether it's a daycare versus a commercial building. And sometimes it's important too to consider what's the zoning for that property. So while it may not be a daycare right now, is there a chance it could be a daycare in the future? And you want to have that conversation with the stakeholders. If this gets sold, is there an action that we should take now so that it's easier to make an adjustment for, let's say, a mitigation system in the future if there's a more intensive use, such as a daycare, where there's more sensitive receptors? Think about it up front and do a little extra homework to make sure that that conceptual site model is robust. And with our control measure, we're preparing our long-term plans that are ultimately going to dictate how the system should or will operate. And again, this is also ties in with that what if scenario. What if the zoning changes? What if somebody else comes in and there's new tenants? And we want to talk too, as part of this risk management idea, what's the criteria for shutdown? What's our exit strategy? When can we turn a system off if that is possible? So in some cases, it really isn't. But upfront, we want to have those conversations because that's going to allow us to manage risk later on. And when I talk about risk in this sense, it's not necessarily managing the human health risk necessarily. It's talking about managing a financial and a liability risk. And we'll talk a little bit about our short and our long-term liabilities as well. So one of the first things we're doing too, as part of this, is we're doing our investigation, we're doing our source assessment. And here we're using our conceptual site model to guide our stakeholders through the necessary steps to understand a current and future building or risk scenarios. And that includes, as we've been mentioning, obtaining the appropriate data to guide the evaluation and control the potential for vapor intrusion now and into the future. And even this itself can be a cyclical process, because every time we collect more data, whether it's in the investigation phase or whether it's in the mitigation or remediation phase, we're constantly using that data to update our conceptual site model. These are not static. And I think that's a trap that certain folks fall into, where they think the conceptual site model is we've done our investigation or we've done one round of sampling. That's our conceptual site model. And that's not the case. And I want to emphasize this. Conceptual site models have to be continuously updated and communicated. We're communicating these new conceptual site models, these revised conceptual site models with our stakeholders. And we're talking about how the findings and how the changes in the conceptual site model are helping, hopefully, to reach stakeholder goals. And we're using this step as well, too, to help design our vapor intrusion mitigation systems. Again, we're using this to account for our current and our future uses, and that's a really key point here. And data management. This whole process from start to finish is an exercise in data management. We're looking at our baseline data, the initial samples that we've collected. A lot of times that's a chemical sample. We're looking at our operation and maintenance and monitoring data that come from an operating system, for instance. And we're taking both of those chemical and operational data, and we're assessing whether there's a potential increase or a decrease in the risk or exposure to building occupants, because that could change our vapor intrusion management approach. And we want to keep thinking about that as we move forward. And we're giving access to these data to stakeholders. And sometimes we're building custom dashboards for our stakeholders, data portals where people can go in and gather the data as they need to. And that stakeholder access to data, it facilitates communication and it helps build that trust. When folks don't have access to the data, they think we're hiding something, or they think the environmental professional is hiding something, or the owner is hiding something. I mean, certainly certain states have requirements to share data with tenants, with occupants, apartment dwellers, but it's a good practice to do that anyways, because a lot of times, I would say almost all of the times, these data are public information. And so somebody will either get these data by you sending it to them or by making a request to a regulatory agency, in which case they will get it. It's much better in this approach that we're talking about here to use this as an opportunity to build trust with the stakeholders. And a lot of times this is residents, this is also the owners, because like I said, no matter what, they're going to get the data. And in this day and age, a lot of folks are Google scientists, right? They're going to get the information, they're going to download perhaps standards, they're going to read about the risks of exposure of certain chemicals. And you want to be able to explain those data to the stakeholders. You want that opportunity. So it's helpful to give them access to data. And if they call you up immediately and say, hey, what does this mean? Even if you haven't done the full evaluation, say it. It's important to say that. Say, look, we here's our initial impressions of the data, but we need a couple more days to go through it to give you the full picture. And at least if you're keeping that dialogue with folks, they're going to stay engaged. They're not going to think you're hiding anything, because you're not, and you're being upfront and honest. And again, it's this upfront honesty and communication that really helps build trust among everybody. And of course, like I said, your regulatory agencies, they're going to get access to the data anyways. You have to send it to them. And really, when they have that data, and sometimes even early data, it helps to support their evaluation of the vapor intrusion pathway and for their own internal and even external reporting. And as we're going through this data management and collection exercise, and this is really when you've got an operating system, for instance, we've got a mitigation system that's operating, we are continually looking at those data to see if we've gotten to our exit condition, or how close are we. It's not that we're taking these data and they just go into a database or a spreadsheet and nobody ever looks at them. The data every single month, every single quarter, whatever your time frame is, that's important to be continuously looking and understanding what do they mean. And if we have them on a dashboard where the stakeholders can look at it, they may see something that looks strange, and you may see it as well. And they may say, what's going on there? It's perfectly okay to say, you know what, I don't know. Or, that's one data point I think we need to get back out and take another look at. our system, take a look at the chemistry, whatever that data point may represent. We want to be upfront about it, but be sure that we're being accountable and responsible in getting back to our stakeholders. And so as we look at an optimized system here for control, for remediation, taking into account all the things we've talked about with our conceptual site model and our knowledge of what's currently going on and what's going to happen in the future, what could happen in the future, we want to engineer the solution for each of our sites based on its unique goals in the environment. And we want to sometimes even talk about our stakeholders' comfort level with using an interim remedial measure in the meantime. And we'll talk about one of those in a case example, conducting source removal as part of this approach. And then even implementing institutional controls, engineering controls, and ongoing OM&M, operation maintenance and monitoring, because that impacts our stakeholders. And a lot of times implementing an IRM, a vapor intrusion control measure, is a pretty easy way. It's a quick way to get into a building and to take care of a potential exposure or a potential risk. It does represent that proactive approach. So rather than wait until a full system, if that's what we're doing, or a full remediation is designed, an interim remedial measure allows us to quickly get in, sometimes really put stakeholders at ease, say, look, we've recognized there's an issue in the building, we're going to take care of it very quickly. And we'll talk about that in a couple minutes. Part of the solution too, a lot of times, is source removal. But how much source removal? That's one of the questions to talk about, because there are short-term and long-term impacts to the community, not just this property, but to the community when we are taking out source material, because a lot of times it involves excavation or transportation of contaminated materials throughout either a residential or a commercial office park, for instance. And the number of trucks and the diesel emissions and the dust and the general disruption to the community, that can have a significant impact. So while it might be helpful to take out all the source material and really try to get down to having a lesser of a long-term impact, there's definitely a short-term impact to that we have to consider and we have to talk about with our stakeholders. And that's the same thing with the operation maintenance and monitoring as well. We may do a more aggressive type of system so that our long-term OM&M needs are less. Again, something to talk to all the stakeholders about. Same with engineering and institutional controls. And this is how we start to get to approaching our long-term and our short-term liabilities. Again, we're balancing the two, we're balancing stakeholders' needs as we go through this process. And so I'm going to talk now about a couple of successful examples we've had with employing this methodology. We're going to highlight knowing stakeholder objectives and how that can facilitate creating a healthy building in a few different ways. We'll talk a bit about source removal, interim remedial measures, and we're going to talk about monitoring for that exit strategy and successfully exiting and terminating a vapor intrusion mitigation system. So this first example is really highlighting source removal. This property that you see here in the middle of construction, it was a former manufactured gas plant and had leaking underground storage tanks. So plenty of source material for contamination here. And the question really was, well, how much of that source material do we excavate? This was a formerly industrial area that was now a commercial area and was slowly turning into a residential area. And so there were a lot of stakeholder concerns about, do we take everything out or do we leave a little bit? Of course, taking more out will help because it'll take that source material away, but we're going to have a lot more trucks driving through the neighborhood and a lot more disruption to daily life in the area. So would it be better to take out less and have less of that issue, but perhaps a longer term OM&M? And so in this one, in speaking with all of our stakeholders and considering everybody's needs and having a complete buy-in with everybody, we decided to take out almost, I think, about all the source material we could. And so this excavation from this angle of the photo here doesn't necessarily look that deep, but if you start thinking that the people in the photo are roughly 6 feet and it's probably 3 to 4 people stacked high is about how deep we are underground, we ended up taking out a significant amount of source material here. And it was ultimately the right decision. It was cut down significantly on operation, maintenance, and monitoring moving forward. And also considering that we're going to have residential tenants in the building that we're going to build here. We put in a robust vapor barrier as a precautionary measure, but maybe not so much as a precautionary measure too, understanding that there were other sources nearby. It wasn't something that we went back and tested after we took out our contamination or our source material, whether or not there was still vapors nearby, but it was a pretty good likelihood that there would be. These manufactured gas plant areas are usually pretty large areas, and we were only working on a relatively small site. And so we did that, and that would protect folks within the building while the nearby properties were remediated. In this next example, we'll talk a little bit about stakeholder needs and the challenges related to that, and also about interim remedial measures, which is one of which you see here on the screen. This site, which we are currently in the middle of designing, well, we finished the design and we are about to put in a full-scale vapor intrusion, well, a remedy and a vapor intrusion mitigation system. This one has everybody involved. It's got an owner, it's got new owners, it had a master tenant, there's subtenants, sublessees, elected officials are involved in this, all the way from the municipal level up to the state level. Everybody's got an eye on this and everybody's concerned about it because of some of the contamination that was identified here. And this one started off with a lot of distrust, and we have worked extremely hard to gain the trust and understanding of the tenants that are there, and frankly, of the agencies that are involved. You know, there's been some issues where lack of response, I will say, is one of the main drivers. And so by working through some of the approaches that we've talked about here in the webinar today, we've been able to build trust. You know, one of the issues that we came up against early on, and this is years ago, was I think there's some real hesitancy to have the folks in the apartments allow us in to collect air samples. I mean, back before marijuana was a little bit more okay to use, folks were using it there and in their homes. And so when we would knock on the door to come in, I think there was definitely some skepticism about, well, what are you here to do? And we say, oh, we're testing the air. What, you know, is this some sort of, you know, program to, identify people who are using this and perhaps get them into trouble? No, it's not. We're not even looking for that, frankly. And whether or not it's present, we don't care. It has nothing to do with the data that we're collecting. And so we were able to back that statement up as well. In the end, we said, here's the data we collected. Here's the chemistry results that we have for your apartment. As you can see, it's nothing that you would associate with marijuana use. That's not, again, what we're looking for. And that went a long way to help mend the fences here and to help build the trust that had really eroded over years and years and years of not following through and lack of accountability. And it also allowed us to then go into folks' homes and be able to install these canisters. This is an air filtration system that has granular activated carbon in it, and it takes out the volatile chemicals from the air. We put these in, and we also install the subslab depressurization system, both as interim remedies, right? It wasn't going to completely clean up the site, but it was going to help limit the vapor intrusion pathway into the building while we design this full-scale remedy that's designed, and we are just waiting on approval. And in this last one, we're going to talk about exit strategy. This is a school, is where this picture was taken from. And as we did the investigation in this former industrial property, we found source material, but we were, as part of the construction, able to take out all the source material. But what we realized is that we also had vapors encroaching in the subsurface onto our property that we didn't know where they were coming from. and we didn't know when they would get cleaned up, if they would ever get cleaned up. But we had to protect people, right? We had to protect the school children. We had to protect the workers that were in that building. And so in consultation with all of our stakeholders, again, we decided to put in the subslab depressurization system. And this ran for, it's run for almost over a decade at this point. But as we were putting this in, we were talking with the regulatory agencies saying, we are putting this in not because we have any source material, but because it exists in the neighborhood. And if it comes to a point where that no longer exists, it's cleaned up, we want to be able to turn this off. And so that was the agreement very early on, was that this was a bit of a measure that's protective, but it wasn't because we caused anything. And so, like I said, fast forward about a decade, we were continuing to monitor this situation. And we got to a point where we said, I think we're close. I think we're at the point where these concentrations in the subsurface are a lot lower. Let's turn off the system and let's see if we have any other vapors that are migrating on. So we collected a couple sets of data, and we were able to show, no, there's actually no vapor intrusion occurring here. There's really no opportunity for vapor intrusion to occur because the soil gas concentrations are so low at this point that other source area must have gotten cleaned up with some of the redevelopment that's occurred. And so we're able to, at this point, turn everything off. And the regulatory agency said, yeah, absolutely. That's exactly what we had talked about right up front. You're at that point, turn everything off, and then let's check in periodically to make sure that there's not another source material or that site conditions don't change that would cause us to turn it back on. But we're able to turn it back on if we need to. It's currently operating as a passive system. So we not redesigned, but we made some adjustments, I should say, to the existing system so that it was passive and would continue to be protective, even if there were some source material to come through in the intervening time. And so now I'm going to turn it over to James, and he's going to dive into a more complex case study where collecting the correct data to develop and understand that conceptual site model, including indoor building airflow, was really key to creating a healthy building.
Great. Thanks, Keith. Yes, I'll be taking us through a case study that really hammers home the importance of the accuracy of a conceptual site model and making sure that we're continually evaluating that CSM as we collect additional data. Let's see, Jess, do I have control? Yes, I do. Great. All right, so this site is in the state of New York and has some features that are common to a lot of vapor intrusion sites, and then a few interesting wrinkles thrown in as well, which is why I think it's worth discussing here. This site is improved with a one-story building with a partial uninhabited basement, as shown on the profile view here on the slide. It has an outcropping bedrock ridge with a shallow groundwater table under the building, which is not necessarily a unique feature. What is a bit more unique about this site is that the groundwater table is essentially in contact with the basement slab. So to inhibit flooding potential in the basement, this building has installed several sumps within that basement slab with active sump pumps that are cycling on and off more or less continuously to manage that very high groundwater table immediately under that basement slab. This site did have a historic source of chlorinated VOCs underneath the south wing of the building that was removed. However, residual dissolved chlorinated VOCs are still present in the groundwater underneath the south wing of the building and the soil gas underneath that south first floor building wing. So the soil gas underneath the south wing did trigger indoor air sampling, which was collected throughout the first floor of the building. Within that south wing, elevated CVOCs were detected, which gave evidence of a complete pathway from the residual dissolved CVOC groundwater impacts through soil gas and then and then through the slab into the south wing, which makes sense. That I'm not showing all the concentrations here, just simplify the slide, but the concentrations from groundwater through soil gas were in line with what you'd expect for the attenuation of those chemicals. So that tracked, that made sense to us. However, the surprising result here was within the north wing of the first floor of the building, which also had elevated CVOC impacts. In fact, even higher than the south wing, almost 3 times the concentrations detected within the south wing of the first floor of the building, which frankly didn't make any sense at all. There was not any contamination underneath the north wing of the building within soil gas or groundwater. So this was initially a bit of a head scratcher. Something else must have been at play here. So before rushing forward, or instead of rushing forward with mitigation measures, given these elevated indoor air results, we performed an airflow modeling exercise within the building to look at the state of airflow, to try to see if gathering that additional information helped us out at all. So we used HVAC plans from the building and also differential pressure across different building areas to look at how airflow is moving through the space. And what we discovered is that within the basement air supply was pushing airflow south to north within the basement to an elevator shaft that was acting as a conduit between basement indoor air and first floor indoor air. So air was flowing up this elevator shaft. And then the HVAC configuration on the first floor was circulating that air throughout the north wing of the building. So by looking at the interaction of airflow within the building, we were able to figure out that complete pathway to the north wing. While not what you'd expect to be a more traditional pathway, we were seeing impacted air flowing either from the groundwater or from soil gas immediately under that basement slab into the basement air, and then making its way to the north wing of the first floor through this elevator shaft. So armed with this additional information and a better understanding of airflow, we move forward with implementing a holistic remedial approach. So first, in the south wing of the first floor, where we did have that more traditional VI pathway, we installed SSDS systems to inhibit migration across that first floor building slab. Within the basement, this picture is a little tough to see, but we sealed those active sumps to inhibit airflow through the sumps from groundwater into the basement air, in order to allow for the continued operation of those sump pumps. We did install vapor vents that vented the sumps to ambient air to avoid any air locking of the pumps. And finally, we modified the HVAC configuration within the basement to positively pressurize that area to cut off or inhibit the airflow from the basement through that elevator shaft that was acting as a conduit to the first floor. So by using this combined approach, we were able to cut off the pathways from soil gas to indoor air while minimizing the active nature of engineering controls, rather than just putting SSDSs everywhere or just kind of rushing into something like that. We were able to implement an approach that really fit what we were actually looking at and minimize the operation and maintenance going forward. So with that, I'll pass it back to Susan, who will be wrapping us up.
Thank you, James. I really appreciate how that case study exemplified the fact that one size does not fit all for a vapor intrusion mitigation system, and that we really have to think about the holistic system and innovative controls to mitigate the potential and keep building occupants healthy and reduce the potential for vapor intrusion to impact them. Jess, oh, thank you. I got control now. In summary, as we've discussed today, developing a strategic risk management approach to evaluate and address the potential for vapor intrusion can effectively and efficiently reduce risks to human health now and in the future, and reduce liabilities. And as Keith discussed as well, liabilities are, not just financial, but rather to property owners and property values and to potential risk, and even the idea of how to build trust in the community and maintain that, because we want to maintain trust. To do this, it's key to understand the conceptual state model and stakeholder goals and make decisions that lead to risk reduction, which in turn can lead to cost savings and promote trust, which in turn can reduce the potential for increased attorney involvement and litigation. We all know that attorneys get involved to help with access agreements and certain things like that. But really the goal is to work collectively with our stakeholders so that we can move forward, evaluate and address the potential for vapor intrusion to build a healthy building, maintain a healthy building, and that healthy environment and community. These decisions include how and where to sample, the end goal of the property, risk tolerance, remedial options, again, as James and Keith exemplified, different approaches, and the termination criteria, because we always want to know what our end goal is. And these have to be reviewed and updated throughout the evaluation and remedial process, because we know that conditions continue to change. And with that, we are going to open up for questions, and James is going to moderate those.
Yeah, so if anybody has any questions, use that Q&A button down at the bottom of the screen and feel free to type a question in. Let's see. Susan, maybe this is a good question for you. Most stakeholders that you've discussed are likely not environmental practitioners. So do you have any advice on how to best communicate maybe some of these topics that might be a bit more complex to folks that don't have the same background as maybe some of the people on this call?
Thanks, James. And you're right. How to communicate is key, right? We say clear, concise, and effective communication. And in that manner, I like to say a lot of times it's a lot of communication. It's having everyone involved, all the stakeholders. That's the property owner, the tenants, maybe the responsible party, the politicians, the regulators, really collectively talking about what we're doing and why we're there to start. And have it maybe be fact sheets and maybe one-on-one communications or phone calls or public meetings or things that they really have the ability to communicate with us and ask the questions. And as Keith showed, and we discussed the data management, right? So having that information out there, being transparent and having maybe a dashboard. And so people can go on the web and look for information at any time. So they feel like they have the ability to access it and to then use it and ask questions. And if they have a question, be open and honest and communicate it. And be responsive in that respect. So really answering the questions, having people understand what we're there for, as Keith said, showing them the data that we're not actually looking for something they may be concerned that we would find. It's like, no, we actually look for these things. We don't care about anything else. And really to build that trust.
Great. Keith, a question here that I think would be good for you to answer. Could you please discuss factors affecting effectiveness of SSDSs installed in existing buildings? So could you discuss factors that affect or have an effect on effectiveness of SSDSs installed in existing buildings?
Sure, there's probably a lot of them that, that are involved in that. Some that we found are, if you're going to put an SSD into an existing building, what's the condition of the slab, right? The subslab depressurization system is designed to negatively pressurize below the slab and maintaining the constant indoor pressure above the slab. But if there's holes in that slab, it's a lot harder to maintain that. So if you have a really terrible slab, and James, you and I worked on one of these projects where in a certain direction, we were able to see, I think it was about 6 feet of influence, but going in the other direction, 6 inches of influence because the slab is in such poor condition when we did our initial evaluation. That can affect things. One of the other challenging effects too is how much access do we have in a site? If we take this as an example that I just mentioned, 6 inches one way, 6 feet another way, does any building owner or tenant want you to put in suction points for that SSD every 6 feet? Absolutely not. I can't name anyone who would want us to do that. So that's another challenge. Where can we actually access? Where can we put piping? Where can we put our equipment? We've got another property we're working on right now. They have a recording studio on the first floor. They don't want any equipment with moving air anywhere near their recording studio because it's going to throw off all of the acoustics. And so we need to make sure that we're taking a very creative approach there. We are burying pipes, we're going outside, we're going up the outside of the building, and we are trying to locate the equipment on yet another property so that there's even less of a chance of vibrations and noise and anything that could disrupt that studio.
Yeah, good answer. So one thing I'll add to that is subsurface obstructions as well. So with a new building, you know exactly what the condition of the subslab is, whether that's a clean sand or where the utilities are, that kind of thing. With retrofitting an SSD in an existing space, you don't. And yes, of course, you're worried about utilities, but also there could, especially in cities, there could be an old pile wall or some old foundation feature that there's no way to know about on the surface, and that can have a significant impact on airflow below the slab. So I think GPR surveys can be helpful in that, to at least have an initial understanding of what's going on under that slab rather than what's there visually. That's another thing that can have a significant impact on negative pressure and influence across the slab as well.
And I'd like to add one more thing to this. Thank you. Just also how people use the building, right? So we want to make sure that we have a negative pressure under the building. And so making sure that actually people don't turn off the systems, making sure there's a way of controlling the HVAC or airflow in the building so we actually don't counter it. So they're, again, thinking holistically about the building, and then it's not just the subslab system or whatever else, but really how are these controls going to implement overall and the use of the building and occupancy. So there are a lot of things to think about in designing systems and things to overcome or potentially not overcome, but play into the design and operation, which I just wanted to add in as well.
Yeah, well said. And actually maybe a good segue to this next question that I see here that I think is interesting, that I think either of you could answer. Can you speak to any VI considerations that need to be addressed with changing climate?
Sure. I mean, I'll throw a couple ideas out. One of the things that we're seeing with climate change is sea level rise. And so especially as we are installing a vapor intrusion mitigation system, whether it's an SSD or it could be, a vapor barrier, for instance, when we're near the coast, when we're near bodies of water, especially with sea level rise, groundwater also rises. And whether that's more saltwater intrusion coming back inland, or whether that's generally everything is rising all at once, we're much more likely to have groundwater in contact with our building slabs. And so as we just mentioned, right, a subslab depressurization system is meant to apply negative air pressure below the slab. But if there's no air below that, because now we're having higher groundwater, that can really mess up a subslab depressurization system or really make it not operational. And same thing with our vapor barriers. If we have salt water getting up into the concrete, concrete's porous and it'll wick that water right up. And if the vapor barrier is not properly designed, or we're not accounting for those changes in with climate change, that's going to fail as well. And so we want to think about those as we move forward, because a lot of times these systems and these mitigation measures are 10, 20, 50, 100-year measures that we're planning for.
I'll just add a couple things to that as well. So if I may, one, not just sea level rise, but with the increased rainfall that we've been seeing, and it may not even be the freeze thaw, right? Depending on where we're actually getting just more water sometimes. And in one of my states, they call it groundwater intrusion, or they call it clean. The rain is intruding. Technically, it's groundwater when it gets in the subsurface and gets in. But many times we're actually developing a vapor intrusion system because of the impacts in the groundwater. And if the water rise is just groundwater, not just because of sea level, then the chemicals that are in that or the compounds that we're trying to address, we also then have to think about being in contact with the vapor barrier. And is the vapor barrier compatible with that chemical? Can it actually withstand what's going on there? Do we have to actually build a system differently, and floating systems, whatever they may be, using even aerated floors or something else to create that void space. The other thing that we've also seen is with warmer conditions, we may have more condensate occurring in the piping of the systems if we're doing a traditional SSD or SVE type system. And so we actually have to think about how to design the angles. We have to think about how to put more knockouts, how to actually collect that water, and what do we do with that water because of the different temperatures that are being created because of warmer conditions. So lots of things that can come into this again, and thinking about what the building is and the conditions and future, not just now.
Yeah, which is particularly important, I think, as Keith mentioned, that some of these systems are, whether or not we intend for them to be used for decades, they end up being used for decades. So extrapolating that out is important. Good question. I think we have time for one or two more. Switching gears from mitigation to investigation quickly. Some jurisdictions do have rather descriptive procedures on sampling protocols, what to do when, how to sample, that sort of thing. Some don't. In the absence of that, do either of you have advice on what sorts of things I might want to think about if I'm designing a vapor intrusion investigative study?
Sure, I'll start, and Keith, if you want to add in, how's that? I'll take it this first time. Really, I think we need to think about what the end goal is, right? We're really thinking about the property use now and in the future, the stakeholders' goals, the property owner, whatever it may be. And if they're interested in a long-term OMM type approach, if they're looking at how much data can we get, or they're thinking about vapor intrusion control or source removal, really thinking holistically about the project, the site, for building that healthy building. And irrespective of what guidance documents say of the type of data, we'll get the data that's required, but we may also get additional data or modify how we do it. So, most guidance documents say collect soil vapor or subslab soil vapor. It doesn't say collect pressure differential measurements. It doesn't say collect information about the HVAC units. It doesn't say collect whatever it may be. It says do a building survey, right? But There are things that we may also want to get so that while we're actually out there, because again, sampling is intrusive, right? We're going into someone's building, whether it be a commercial, industrial, home, whatever it may be, we're going in there and we don't want to really have to disturb them so often. So the more we can get at that time so that we can make decisions and that we can actually come up with what type of remedy maybe would be appropriate at that point, as opposed to coming back and doing a pilot study or doing something else. So really working with understanding end goals, understanding what we can do, what the bare minimum is, what's required, and then additional, and communicating that. And so that people understand what we're going to be doing at what point.
Yeah, and I would add to that, and in that vein, one of the things that we will look at from time to time to help us predict how long a system might last is, do we have evidence of biodegradation? So as we are looking at what's in the subsurface, what's in the air, the soil gas, we're looking for that evidence, because that may tell us, hey, there could be a way that we could design some additional steps and additional remedy that could enhance this such that we don't have to run a system for so much longer in the future. So it's again, like Susan said, being strategic. When we're out there, let's get all the information that we need to answer these questions that allow us to do that balancing between short-term liabilities, long-term liabilities, short-term impacts, and long-term impacts.
Yeah, well said.
And I'll just add, yeah, I agree. And I was just saying, I think, the examples that we've shown today demonstrate that it's not just sometimes a VI control, right? Most people consider vapor intrusion controls an interim remedial measure because the source is still there, right? So collectively looking at what else can we do? Maybe we need to do something in the short term to address exposure or potential exposure, but really long term, what can we do to address it? And that's enhancing biodegradation, source removal, whatever it may be. And that's that strategic approach to keep on going back, re-looking at this every year when we do our annual reports or our monitoring. What else can we do? What can we enhance? This is not a one size fit all. We don't do it and we walk away, but really the collective continuous evolution of what is necessary and appropriate.
And one other thing that comes to mind too is while we're there doing the work for the investigation, we're also looking at the building, right? How's their HVAC system designed? Does it bring in fresh air? Is there a chance that we could positively pressurize the space with existing equipment? Whether or not we identify that vapor intrusion risk or issue that needs to be mitigated as part of our investigation, we're already thinking ahead to the solutions. And are there simple things that we can do, such as positive pressurization, adding carbon air filters to the existing HVAC, not even bringing in the little canisters, the R2D2 units that I showed earlier, but can we just modify the existing HVAC so that it's already done? And that may be enough of a first step, or that may be a final step, depending on what the issue is. But we're not just looking down into the ground, we're also looking up into the building as well.
Definitely, definitely. Well, folks, I think we're just about out of time here, but Susan and Keith, thanks very much. Thanks all for joining, and keep a lookout for invites for some future webinars on some other great topics. Thanks all.